introduction. So today I'm going to present a little bit about industrial AI for future-ready paper mills. And it's basically one operator-facing intelligence layer for mid-size recycled and fiber mills. So why are the discussions going on right now? It's basically because of three pressures. The three topics of our conference, policy, sustainability, and technology. And they're continuously going pressures in the industry right now, whether it's through the governmental regulations or internal policies being created at individual mills. So the backbone of the industry right now is paper mills have capacities of 50 to 300 tons per day, 1 to 2 machines, maybe 3 to 4 at most. And there's hundreds of these mills that exist in the Indian market right now. But they have the same obligations as the giants around the world, with a fraction of the capital to invest. Tighter margins, same market. And the forces that are getting placed on them are the exact same. As I said, one of them is policy, meaning governmental regulations, audible, fiber, and recycled content traceability, ESG disclosures, net zero and PAT, emission targets, whether they're internal or through governmental policies, and then tighter regulations for effluent norms. And then another one is markets. A trend that we are seeing a lot, and especially with the export market, is that customers are now requiring verifiable proof of sustainability, whether it is through footprint verification, traceability of raw materials, and even specific water consumption requirements and thresholds. And lastly, the technology. The technology keeps booming and has advanced in much faster speed than previously expected. And in the results of that, there's a lot of availability of the technology that is out there. For example, the data costs and data storages are now falling in prospect to what is the normal dot of the world. Actually, storing data is not becoming more expensive, but it's falling. It's actually the production-ready models that are becoming more and more prevalent and helping do that. So why, the biggest question is, why aren't mills using it right now? And why are, all these discussions happening? And I think a lot of the colleagues touched on this because none of the systems talk. DCS, QCS, ERP, lab, and maintenance, everything is disconnected. Nothing is integrated within itself. And there's only reactive-based decisions happening at the moment. Energy is a black box. How to reduce consumptions per ton energy consumptions, utility consumptions, is very difficult. And knowledge, and one of the biggest factors right now in the market is that the expert knowledge is slowly leaving the field. A lot of the generation that has been around the industry and been around the market for the last 30, 40, 50 years is slowly retiring, and that knowledge transfer doesn't happen as quickly as it needs to the next generation, such as myself and many of the other people here. So the response that needs to happen is one intelligence layer over the entire mill. Many of these layers already exist at a lot of mills. For example, connectivity and edge. These exist with the DCS, QCS capabilities that exist already. Data platforms. Data exists, it's just a matter of how you collect it and store it. Now, where the intelligence layers need to get added is that third and fourth layer. The AI and analytics portion will overlay all the data in the mill, and along top of that, providing decisions and insight into your mill. Real-time, predictive, even multilingual. It's moving in a different direction. So data becomes a decision when it carries meaning. So context linked to tags to meaning. A felt role-bearing change event, during a great change. So So this type of information, rather than just data, just numbers being shown to operators, can allow people to have a proper review of exactly what is happening and able to do proper analyzing and allow them to even think further, how can I improve things that may not seem like major issues at the mill. So this is one of the examples on how we can improve. One is quality, right? So we have process tags, refining, freeness, vacuum, steam, dryer, and ash content. These data already exist at the mills. Now what we can do is we can create a gradient boosted model, whether it's per grade, per furnish, so that way we can predict and forecast burst strength, RCT, CMT, basis weight, even moisture, minutes ahead of the actual value, the lab values. And, people may ask, well, what is the guarantee on the accuracy? Well, it has a validation, right? Every reel is scored. If there is a drift, you recalibrate, readjust as the actual values are entered. It's an instrument, not advice. Here's an example of forecasting. So with this, we're seeing 1.8 newtons of mean absolute error. This is RCT values forecasted versus the actual lab RCT values. And the forecasting was happening about 8 minutes ahead of curve, with 0.97 R squared against the lab and across 40 reels. So as you can see, while the mean error is within the standard range, and we're able to allow a 8-minute lead time for the forecasting. So when major effects do happen, you're able to fix them online before it gets to the lab and before the whole reel and roll is produced. So you're able to adjust and fix issues at that time. And then reliability. This one is failures days to weeks early, if we're talking about maintenance aspects. One of the major things that I've been discussing with a lot of people in this past few days is how we can stop unplanned downtimes. And this is something that's very important. Signals that can be watched: vibration, bearing temperatures, motor currents, vacuum, dryer loads. These things can be watched and reviewed and analyzed in order to catch failures days to weeks early with a high percentage of accuracy in order to prevent unplanned downtime and to do a proper analysis of how your machine is running. And then energy, the biggest cost factor in any mill. Whether we're talking about all utilities, steam, power, water, and gas, about 35 to 45% of all variable costs at a mill is within these 4 factors. So, it is a major benefit of having these loops created so you can get a better curve and slowly improve that aspect. One of these, this is a standard 16-week cycle that we ran, where we had improvement of 6% less energy within 6 weeks. We went from a starting of 1.47 to 1.48, all the way down to about 1.37. And as you can see, the trend is curving down, so a continuous improvement will keep happening, with zero CapEx turnovers, just improvements and on the functionality of the parameters. 10 to 20% unplanned downtime during ramp-ups, 3 to 7% less steam per ton consumption, and 30 to 50% faster grade changes. And the biggest factor is always on knowledge capture. So as many people said, it's not something that's going to show immediate improvement. It'll take time, 6 months, 1 year. But by that time, it'll be an expert in its field more than any of us can ever look into it. And another great thing is that it won't stop at that 1 year. If we look 10 years down the line, it'll have knowledge of 10 years within its grasp. So it'll be learned and continuously growing for as long as it is implemented at the mill. And another question that came up earlier is what kind of expected payback periods we expect. And, people mentioned 6 months to 12 months. We're seeing a typical 12 months to 18 months, but it highly depends on the level of investment we're putting in the beginning stage, how much incorporation we're doing at that first stage. And then through all the compliances, the policy compliances fall out, right? With factory traceabilities, lot by lot traceabilities, furnished to real, KPIs with a full audit trail. These become standards because we're collecting the data and we're keeping it stored, and we have that availability at all times. Effluent, continuous pH, BOD, COD values with alerts, so you're able to fix the issues before they hit the discharge, before they hit the city, and you're faced with any kind of issues. And then PAT and carbon emissions as well, helping you improve your discharges and emissions on that point as well. And the limit on this, one greenfield site ranges need wider proofs, right? It's something new. We'll have wider ranges until in the beginning stage. But as we move more and more into it, like we said, 6 months to 1 year, those limits will get smaller and smaller. And as the years continue on, eventually we'll get to a point, and something that was discussed yesterday, the Industry 5.0, there's a lot of pushback, but eventually these factors, these implementations at this stage will move us into that 5.0 standpoint. And I know it's a big struggle to want to let go of that control at a mill, but eventually, these factors will move to that point where we have to let go of these controls, and eventually give, if not full control, certain controls over to help improve our processes. So basically it's the 3 pressures and 1 machine verifiable data. Thank you.